What's up, guys? My name is Jessica Stepek, and today I'm going to be showing you about the special binomial products. So the first case that we have is called the product of a sum and a difference, where we have two terms, A and B. So here we have A plus B times A minus B. So how is this going to help you? Well, if you know that when you have the product of a sum and a difference, it will always give you this answer, which is called the difference of squares. So let's look at a real life example. Here I have x plus 3 times x minus 3. If you notice, the first term, x, is repeated, and the second term is repeated also, 3, and its opposite, negative 3. So instead of having to go through the whole process and multiply it out, you know that the solution would automatically be the difference of squares. So this would be equal to a squared, which we say is x here, x squared minus b squared. So here our b is 3 squared. So to simplify this, we just have to multiply out the 3 squared, and our solution would be x squared minus 9. So here we have the second and last case of the special binomial products. This one is called the square of a binomial. As you see, I have two cases. I have, when we have a sum, a plus b, that binomial is squared. And the second case, a difference, where we have a minus b squared. So as you can guess already, this is called the square of sums and the square of a difference. So first of all, with the square of a sum, it would have to be multiplying the same binomial times itself. So we would start with a plus b times a plus b. After we multiply this out, it gives us a squared plus 2 times both terms, a, b, plus b squared. Now, when we apply this to the square of a difference, it will give you a similar result. Watch carefully. So here you can see the square of a difference gives you the result with a squared minus 2 times the first term and the second term plus b squared. If you compare the square of a sum and the square of a difference, it's very similar. The only thing that differs is the middle term, with the square of a sum being positive and the square of a difference being negative. So here we have the final formula of the sum of a square. So now we're going to do an example with 2x plus 4, the quantity squared. So here a is 2x and b is 4. So we can just plug these values into the final formula like this. Equal a squared, so we put in parentheses 2x squared plus 2 times a, which is 2x, times b, which is 4, plus the final term b squared, 4 squared. Then we further simplify the quantity 2x squared. We have to square each term inside of the parentheses, which would be 4x squared, plus 2 times 2, that's 4, 4 times 4, 16, times x, plus our final term, 4 squared, which is 16. As you guys can see, this saves you a lot of time by using this formula. So here we have our last case, which is the square of a difference. 3x minus 2, the quantity squared. Here you have to be very careful because we're working with a minus. So first of all, we define what is a. A equals 3x. I'm going to write that over here. A equals 3x. And the second term, b equals 2. B equals 2. So then we plug it into this equation to get our final solution. So we have a squared, 3x squared minus 2 times a, 3x, times b, 2, plus b squared, 2 squared. So then we simplify, that's equal to 3 squared, which would be 9x squared, minus 2 times 3, 6. 6 times 2, 12. X plus the last term, 2 squared, which is 4. So if you look at this final solution, you notice the last term is positive, the middle term is negative, and the first term you can see is the a squared. And remember guys, that the biggest mistake is not making a mistake at all.